Looking at example 5 from section 6.6, shape of a colony of bacteria on a petri dish is circular. Find the approximate increase in the area if the radius increases from 20 to 22. So we're supposed to use differentials to do this. I'm just going to actually add a little piece to this problem and show what it would be if we didn't use differentials, and then compare the answer to what it is when we do use differentials. Without the differential, the way that we would do this, we would want to find the change in the area. So the original radius is 20 given, and then we're going to increase that by 2. So how do we find the change in the area without differentials? This would give us the exact change. So basically we just take the larger area, which is r being 20, and then adding that change to it. So basically pi times 20, the delta r in this case is 2, and then subtract from that the original area of 20, and just notice what you get when you do that. That's going to be pi times 22 squared, which is 484, and minus pi times 400, and that gives 263.9, and the units on this would be square millimeters. Okay, now that's not what the problem is actually asking for. I'm just doing this to show that this is a bit more work to do that. What the problem wants us to do is find with the differential. So again, I'm just emphasizing why we use the differential. It's easier to calculate. So that's dA, that's the approximate change in the area. And so to do that, we just use the derivative. We get 2 pi r, and this would actually be dA dr, then you multiply by the dr, you get the dr here. So dr is the same as delta r. Okay, in this case it's 2, so we're going to get 2 pi, r is 20, that's the same r as this, dr 2, so 20 times 2, 40 times 2 is 80, that's 80 pi, and if you put that in the calculator, you get about 251.3 square millimeters. So you can see the answers are not that far off. Again, this is the approximation. This is the exact change in the area. This was clearly easier, and for the most part, using the differential is a good approximation, provided that this change value, this delta value, is not that big. The reason the error here is a little bit, not that great, is because this delta value here is relatively large. Usually we consider this delta value to be fairly small, like 0.1 or something like that. But anyway, this is with the differential, that's what the problem is asking for.